Welcome back, folks. So we're going to back up a little bit here to the automatic frequency control again. And I did quite a bit of research on this. I checked all my components. I even pulled out the varactor and checked it out individually. Everything was fine. And it's been a long time since I've done anything with a varactor. In fact, it dates back to my third or fourth year in university back in 1980. I don't remember much about them, so I did a little bit of research about them, and their effects are over a very limited range. So they're just basically like any other diode, except for they have a larger and more controlled depletion zone. And that depletion zone, as you put voltage across the diode, that depletion zone either grows or shrinks, and that's what changes the capacitance of them. But the effects are very, very small, and it's just over a small voltage range. So I decided to try this again, and I did, and I'll show you the results. My problem before was, I wasn't putting enough input in. So I've upped the input to 30 millivolts peak to peak from the oscillator, and I'm no longer changing the frequency in hundreds of kilohertz, but in tens of kilohertz, because that's what you need to do. These receivers are so sensitive that a radio station that's off by 100 megahertz here or there is going to be a different radio station. And when you down convert that to the intermediate frequencies, you're down around about the 10 kilohertz range rather than the 100 kilohertz range. We have to change the frequency in tens of kilohertz or single kilohertz. And so that's it. We're at 10.7 megahertz and 30 millivolts peak to peak going in. We're going to first go up in frequency by 10 kilohertz. And you can see that it immediately starts going up. And this is enough change in the voltage across that diode to change its capacitance significantly enough to change the oscillation frequency of the local oscillator to keep it in tune. So it is going up as we go up, and then if we go back down to 10.7 megahertz, and now we'll go down, and indeed the voltage does go down, and that's perfectly within range. I made a mistake last time of A, not putting enough input into it, and B, changing the frequency too much. So that is working as described. I wish they were a little bit more clear on here. They could have given us a better idea of how much input to use and how much we should change the frequency in order to detect this. But they didn't, but I learned about it, and now I've told you guys about it. So let's get back to our previous build portion of this. And I'm just going to carry on from this point. So let's carry on with the RF amplifier assembly. I just noticed something here with L1 and L2. There's absolutely no way you can arrange them like this because L1 has been wound the wrong way. Now, I don't know if I'm supposed to take it off and wind it back the other way. I guess I could find a form roughly that size and see if I can rewind it. But L2 could be straightened out a little bit. But there's no way I can bend L1 to fit with L2, and turning it around 180 degrees is not going to do anything. It's not going to improve the situation whatsoever. So I am going to have to look at trying to rewind this coil here. Let me pop it out and see what we can do about that. Okay, so it looks like a 3/16 drill bit is just about the right size. I'm going to go and try and rewind this and come back. Okay, that's about the best I could do. It's got a bit of a gap in it, so it's not ideal. I think it needs to be gapped out there anyway at some point. Am I correct? Yeah. Three windings, two windings, one winding. That might work out for us. Okay, I'm gonna have to get the solder sucker out and make room for this again. Okay, so let's read the bias on Q1.
I couldn't find 11 bodies moving on in your Kindle library. You can buy it on Amazon.ca.
Well, we'll ignore that interruption. Yeah, 1.63, so about 1.6 volts, perfect. Let's carry on. We're going to proceed on with the alignment with RF generator and oscilloscope. But let's see what we can do. Switch to the FM section, connect your RF generator and oscilloscope to the circuit as shown in figure 55. So we want the come in here at test point 14, and we want to take the oscilloscope off over here at test point 2. All right, let's set those up. Okay, we're all set up to do the IF alignment. We have the generator set up as requested, 10.7 megahertz modulated at a frequency of 1 kilohertz with a deviation of 22.5 kilohertz. Although I don't put that in there, that's the way it should be set up. And we have the scope is set up to, I put it at 20 millivolts per division. They've asked for 50, but I think that we're going to see something a little bit lower than normal as usual. So I'll put it there. If I have to adjust it, I will. And then turn on the power. Let's get the scope up. Turn on the power and adjust the level of the oscillator until a 1 kilohertz signal is seen. It looks like we got something there. Okay. Yeah, see, so it seems to top out around about 8 millivolts going in. I'm only getting about 40 millivolts peak to peak. And then we're supposed to adjust T1 and T2 to peak it further, but I think they should be pretty well adjusted. We adjusted those further back, but let's have a go at it. See what we're getting here. We're going to turn it up one more step to 10 millivolts on the scope. Yeah, can't seem to improve much on that. We'll try T2 here. No. So yeah, we've got our peak anyway. We didn't have to do any adjustment. And we got kilohertz coming through to the speaker. Okay, we'll call that a win. Now, page 58. We're going to do the oscillator alignment. All right, let me set up for that and we'll be right back. Here we are getting ready to do the oscillator alignment. But truth be told, what I normally do is I'll just do a sanity check. I'll set up for it. I'll do a sanity check to see if we're starting off in the right place, if there's something on a miss. And in this case, there was. So the FM oscillator stage should be running between 98.7 and 118.7 megahertz. Well, it wasn't. It was starting out around about 70 or so. I just couldn't get anything to work right. I went through the circuit completely from beginning to end. I pulled out components and tested their values, and they were all kind of within their stated tolerance, but I guess the tolerances are just off the wall as far as their added up state is concerned. And this is L3. So what would have required me to do to make it measure down to the small size, but it's the way it's built, on a 3/16 inch form with number 22 wire. It's got 5 windings. It should be about 0.1 microhenry, but it's no longer suitable. What it needed to do is drop down to 0.07 microhenries, and in order to do that, I would have had to stretch it, and I couldn't. The board wouldn't let me do that. It would have ended up being some sort of fan fold, and that wouldn't work right at all. So what I ended up doing is I ended up putting in a 4-turn coil, which brought me right in line. And then with a little tweaking of the capacitor on the tuning assembly here, I was able to get the oscillator right in line. So basically, I've already done this entire alignment section here. It only took me 6 hours, and I didn't catch it on camera. I doubt you would have wanted to listen to me. And I figured, well, the only thing is to go after this coil. And we changed the coil, and we did that. So let me take you through just the basics here, and then we'll go on to the RF alignment. Okay, let me get the thing turned on here. Oh, by the way, I can no longer use my Siglent function generator. It tops out at 60 megahertz. So I'm using this Tiny SA Ultra. I just picked this up maybe 2 months ago, and I've done very little with it. But one of the reasons I did pick it up is that it's got a full out sine wave or square wave function generator in it, and it'll do things like FM and AM modulation and everything else. So it's a real handy little device. And on top of that, it's a spectrum analyzer. But I'm using this now to go from the 88 megahertz to the 108 megahertz that we have to. So I've got it set up as you can see here, frequency 88 megahertz. I've got a minus 30 dBm value here because I was getting quite a bit of distortion. There still is quite a bit of distortion. There's a lot of level going in straight into the antenna area. And I'm clicking right onto the antenna. I'm not going to bother clicking onto test point 14. It doesn't really matter. They're both the same. It's just more convenient for me to click on here. And I've got the modulation set up 1 kilohertz at 22 kilohertz deviation. Okay, there we are, right? We're right down the bottom of the scale where we should be. Peak it there. So we're peaking at around about 56 millivolts. And of course, I've got everything else set up the way they recommended in the book. I've got the scope on the output, and we got the function generator going in the antenna. Another thing I should tell you what I did here. I've limited the scope to 20 megahertz. And I'm using this lower end probe here, and I've got it in 1 times mode in order to try and eliminate some of the noise that I pick up around here, so we get something that's semi-sinusoidal. It's not really, but you can see it coming in at 1 kilohertz. I believe that all this funny stuff that you're looking on there is caused by picking up noise in here, and I think that'll go away if we get it upstairs. Once we get it tuned up and listen to a radio station, you won't be hearing this noise. You can also hear it in the sine. You can hear kind of a roughness to it. So now we have to get our magic wand here, and we're going to start off with the brass one, bring it close to L3. Now if it increases, then we're going to have to change it, but I don't think it's going to increase. No, it goes down. And again, with the iron core, it's going to even make a bigger change. Yeah, it doesn't increase the amplitude. So like I said, I got that tuned pretty well during the course of me trying to get the thing working again. Using the brass, if the signal in the scope increases, that means the L3 needs less inductance. To remove inductance, carefully spread it apart a little bit, and that's basically what I had to do. And then if you put the iron end on it and it increases, then it needs more inductance, so you have to squeeze it together to get a little bit more inductance. So now we're going to go up to 108 megahertz. This is all touchscreen too, so it's pretty neat. And of course our signal will drop off there until we go on up to the other end of the scale. And there we are near the top. So we'll tune it to maximum. Take our magic wand. Try the brass first. No, that only detunes it. And try the iron. That detunes it even worse. Okay. All right. So, like I said, I did get it tuned up during the course of those hours of investigation. And so that section is pretty well done. Now we've got to move over and try and tune this section, which I haven't done yet. So that could be a little bit more interesting for you. But like I say, this was really tough. I mean, if any of you guys have had similar problems with your tuning just being way off, it could be for the same reason, that you've got a little bit too much inductance there altogether. And either, you got to get that thing and spread it out, or wind your own little coil here. And like I said, it's on a 3/16 inch form. I use a 3/16 inch drill bit. Okay, so let me set up for the other one, and I'll be right back. Okay, we're all set up for that, and I did the sanity check. It doesn't look too bad. So we're running now, everything's the same except for running at a frequency of 90 megahertz. I've got it tuned in to that, and now we just bring out our magic wand here. And the signal to scope increases means coil 1 needs less inductance. Carefully spread the coil apart. If it reduces, then it needs more inductance. Okay, let's see what happens. No, it goes down. Okay, now we switch over to the iron. It doesn't increase, but it doesn't decrease much either. So it goes from, yeah, it does. It decreases a little bit. From about 53, 54 down to about 51, 52, 50. So we're good. Now we go up to 106 megahertz. And tune the tuner up there. Peak it out. A bit more sensitive up here. There we go. So we're looking for an increase here. There's a slight increase. It means the coil 1 needs more capacitance. So let's increase the capacitance a little bit. Try that. That's good. It stays the same. Now try the iron one, and if it means it needs less capacitance. Nope. I think that's good. Decrease a little bit. And now carefully adjust the FM antenna trimmer until a peak is seen. So that's the other pot over here. That's around about our peak there, 57, 58 millivolts. Okay. You peak these steps until the signal tuner on the scope decreases to both ends of the magic wand. Okay, so let's see what happens now. It's the brass end. I think that's an overall decrease, and then the iron end. It doesn't do anything. All right, this concludes the alignment of the FM radio section. If no stations are heard, verify that the FM signals are present in your location. Okay, I know we have 2 radio stations in my location, so I'm going to grab the camera and go upstairs and try to tune them in. According to the odor. So here we go. I don't know how loud this is for you guys. It's pretty loud here.
See, this is why Airbnb scares the living daylights out of me.
I have to wait until they had something on that I wouldn't get a copyright strike for, so you could hear it. This is one of the stations that we have locally here.
I hope they don't say anything about
it's coming in pretty good.
Back, but holy moly, does that scare the bejesus out of me? Because wow.
Now the other station is just down the dial a little bit. I'll get a copyright strike for that. Anyway, well there it is. It's it's working very nicely, actually. So a pretty clear tone to it. It's not distorted very much. It depends on, of course, how carefully you tune it in. And it's fairly sensitive. Yeah, I think it's had some little hoops to jump through though to get it going, especially that automatic frequency control and the coils. Both L1 and L3 gave me a little bit of trouble there. But other than that, well, that's it, guys. It's all finished. I know that there was some stuff like in the last section there, my scope wasn't running, and I kind of breezed through some of this stuff because it was already set up due to some of the trouble I had. So if you have any questions in particular about this section, feel free to leave them. And, you know, thanks for joining me for this trip. And thanks, Hank, very much for setting it up to me and allowing me to do this. Catch you in the next one, guys. Bye-bye.